Right.
Yeah, right. So yeah, I can say I cubed is equal to I squared times I to the first. And like I said before, like this I squared term is a term you always want to be like looking out for. Like you want to like try to get that term if you're manipulating things. But yeah, so yeah, I can say this is I squared times I to the first. And then I squared, do you remember what that was equal to?
Um, yeah, that's just one, I think, a negative one.
Yeah, it's equal to -1. Okay, and then I to the first, anything to the first power is just itself, right? So then I can just say I to the first is just I. And then, -1 times I can just say that's equal to negative I, right? So yeah, I can say I cubed is equal to negative I, and then I squared is equal to -1, and then I to the fourth is equal to is equal to 1. So let's move on to the third slide now. So okay, so let's say we have I to the 0th power. So anything to the 0th power is still going to be 1, even if it's like an imaginary number, okay? So I to the 0th power is going to be equal to 1. Now I to the first power, anything to the first power is just itself. We can just say that this is equal to I. And then I squared, what did we say that was?
N- Um, -1.
Yeah. And then I cubed, what did we get that as?
Um, I think it was just I think it was -1 or
Not not -1. So okay, so another way to think about this is like um I can multiply I can multiply another I onto my I squared to get I cubed. Right? Does that make sense? So like if I had like x squared or something, I can multiply another x onto that to get what x cubed is. So if I have I squared here and it's equal to -1, I can multiply another I onto this, and then whatever that'll be equal to I cubed, right? So if I multiply an I onto -1, that gives me negative I, right? So then we could say I cubed is equal to negative I, right? Um, you can see this like multiplying by I in every step that we have here, right? So I can multiply from um, I to the 0 to I to the first power. I can think of that as just like multiplying by I, right? And that makes sense here because I have like 1 times I is equal to I, right? And then from I to the first power to I to the second power, I can think about that as multiplying an I. And then that makes sense because if I have an I times I, that's going to be equal to -1, right? And then, like I said there, we can think of this as just multiplying by I, right? And then we have -1 times I is equal to negative I. So I cubed is equal to negative I. So does that make sense?
yeah.
Okay, and I to the fourth power, do you remember what we got that as?
Yeah. Um, that
See, again, we can just go from I cubed to I to the fourth. We can just think of that as multiplying by I, right? Um, and then if we have negative I times I, so you have negative I times I, we can take out the -1 and we can group the I times I together, right? And then I times I, that's just like I squared, right? And I squared, that's just -1, right? Because I squared a -1, we're squaring that. So the square and square cancel out. So then we just have -1, right? So I times I is going to be equal to -1. And yeah, -1 times -1. That's equal to 1. So yeah, so -I times I is going to be equal to 1. So then from I cubed to I to the fourth, we can say that's 1. And that's also what we got before. Okay. So now, what if we had I to the fifth power? Um, can you try and figure out what that would be able to?
Um, okay. Um, I'm kind of confused. I tried figuring it out, but I can't really figure it out.
Okay, so there are a lot of ways you can approach this. Um, One way is to just use the tactic like I was talking about before, where we have our I powers listed out. Um, and to move to the next I power, we can just think about that as multiplying by I, right? Because like on this side, it's obviously just going to be multiplying by I every step, right? Because you know we just have we're just like the power of our I is just increasing by 1, right? And to get to that, it's just like multiplying by I, right? So from like each of the right steps here, we can also think about that as multiplying by I, right? So to get from um, to get from this I to the fourth to I to the 5, you can just think about that as multiplying the 1 by I. So uh, so do you get that now? Do you know what I to the fifth would be equal to?
Um, um, would it be uh, would it be a -1?
Not quite. So how do you get negative?
Um, I tried um I tried multiplying I with the square root of -1, and I'm kind of confused.
Okay, um, so if you look on the third slide, right? Like, oops. like we can just focus on, like all I'm looking at is this step, right? So like from I to the fourth to I to the fifth power, to get from I to the fourth to I to the fifth, I can just think about that as multiplying by I, right? Like I can also think about this as like manipulating equations in algebra, right? So like I know that I to the fourth power is equal to one, right? And then, I can multiply I onto both sides, right? And the equation still holds. Like this is just simple algebra, right? Um, but if I have I to the fourth times I can say that's equal to I to the fifth, right? If I had like x to the fourth, x to the fourth is equal, I don't know. If I had x to the fourth, I multiply that by another x, that's just always going to equal x to the fifth, right? I could say that's equal to x to the fifth, right? Does that make sense?
Yeah.
Um, like you can think about it as like x to the fourth is like four x multiplying by each other, and then I'm multiplying by another x. So then in total, there are five x's multiplying by each other. So it's just equal to x to the fifth. And you can also think about it as like the exponent property we discussed before, right? So like if I'm multiplying it by x, it's like I'm multiplying by x to the first power, right? And then if I'm multiplying these with the same base, I can say it's going to be the same base to the power of these numbers added together. So 4 plus 1. So yeah, the c goes to x to the fifth. So with I, it's the same thing, right? I can treat I as if it were a variable. So if I had I to the fourth times I, I can just treat this I as I to the first power. Anything to the first power is just itself. And then by exponent properties, like the same thing I just did, this is going to be equal to I to the 4 plus 1. It's equal to I to the fifth, right? So, so this I, so on the left side, the I to the 4 times I, um, what can I say that's equal to? It was just the same thing that I showed you.
Um, well,